Okay, so unit 2, aldehydes and ketones. Now there are going to be 2 subunits for unit 2. Aldehydes, ketones, and then carbohydrates. Now that carbohydrates is our first biochem unit. Now what makes this unit tricky are the structures. Carbohydrates can be very large, and you're going to need to know quite a few of them. You don't need to know monosaccharides, di, oligo, and polysaccharides, 4 groups. So the basis of aldehydes and ketones is the carbonyl group. So this is in the middle. Okay, now this is no exceptions. Aldehydes can only be on the end. Ketones can only be in the middle. Now you can have a double aldehyde. In fact, a very common double aldehyde is you experience every day at home cooking. When a seed oil oxidizes, it produces a 3-carbon double aldehyde, called malonaldehyde. It's a very dangerous little molecule. It binds protein in a bad way. If that protein is in an enzyme, that enzyme stops working. When you get down to the bottom of your seed oil, like canola oil or something like that, it's sticky. That stickiness is polymerized oil. Like it's sticky. That's why restaurants have to change their deep fryer oil very regularly. It polymerizes as well. Okay. Also present in that stickiness is this 3-carbon aldehyde. Not good. So another reason why cirrhosis of the liver is so bad is because it's from alcohol oxidizing to the aldehyde. Okay. Anyway, this C double bonded O is called a carbonyl group. Formaldehyde is the simplest aldehyde. Very dangerous. It's used commercially in glue. Like when they build a new house, they have something called OSB. And that's wood chips glued together with this formaldehyde-based glue. The problem with a new house is after the house sits for about a year, especially around here, it gets over 100, that formaldehyde starts leaching out of that glue in your walls. And if you live in the house, you're going to be breathing in that formaldehyde. They use formaldehyde to preserve tissue. For example, when you are in a zoology class and you're dissecting animals that have been preserved, they're preserved in formaldehyde. If you're breathing formaldehyde, it's going to do the same thing to your lung. So it's not nice stuff at all. Acetone is another one. Acetone is the simplest ketone. It's in between the 3 carbons with the carbonyl group, so it's a ketone. Also, not good for you. A nail polish remover is half acetone and half methyl acetate. Not good stuff. All right. We name aldehydes. It's got an AL ending. Now, you don't have to say where the ending is, because it's always on carbon number 1 by definition. So you may put the 1 there if you like. Most textbooks do not put it there. So it's on the end here. Now let's look at this one a little more closely. Is that the backbone? It's not the backbone. Why is it not the backbone? Say again? That's right, it goes up. That's the backbone. The backbone has to, no exceptions, has to include the functional group. The first time I drew the straight line across, that aldehyde wasn't part of it. So now we have a 2-carbon ethyl branch. So this is 1, 2, 3, 4. That's why it's called a butanal. And it's got an ethyl at branch at carbon number 2. Now aldehydes automatically name carbon number 1 for numbering. Now, when you write Al, be careful that the A looks like an A and not an O, because if it's OL, it's an alcohol. So think of aldehyde, Al.
The functional group is the oxygen.
Hmm?
The functional group on this one is the oxygen.
It's a combination of carbon double bonded oxygen, yes. This is the second step of how your liver deals with ethanol. This is how your liver detoxifies alcohol in your liver. It converts it to an aldehyde. It's called alcohol dehydrogenase. So if you have a lot of that enzyme in your liver, you're in good shape. The second step of detoxification is taking the aldehyde it creates and further reacting it with something called aldehyde dehydrogenase, which converts it to acetic acid. And if you've got a lot of that enzyme in your liver, you're in good shape. If you lack those enzymes, alcohol dehydrogenase, aldehyde dehydrogenase, that attacks your liver and causes cirrhosis of the liver. So your liver's function, when you drink a lot, focuses on detoxifying that alcohol, the subsequent aldehyde, the subsequent acid. Anyway, it's called acid aldehyde because it's based on acetic acid. So ketones are named ONE. So again, the backbone has to include the functional group. So in this case, it's going to be that. You've got a carbonyl group on a ring. It has to be a ketone because there are no ends in a cyclic compound. Okay, so this is a 1, 2, 3, 4, 5 backbone. So it's going to be a pentanone. The carbonyl group is on carbon number 2. You have to designate what carbon the carbonyl group is on. We have a branch at carbon number 3. So we have ALs for aldehydes, ONEs for ketones. Acetone is the simplest ketone. If you've ever been in the painting business or the machining business, MEK, methyl ethyl ketone, very common solvent. Now, intermolecular forces. Okay, we've got the alcohols. So the alcohol is more polar than either an aldehyde or ketone. They do not have hydrogen bonding. Alcohols do. So the alcohol, equivalent weight alcohol is going to boil at a higher temperature than its counterpart, aldehyde or ketone. So if we look at a graph, the aldehydes are going to lie in between the alcohols and the alkanes. So they're more polar than an alkene or ether, but they're less polar than an alcohol. Now this is slightly negative. So this being slightly negative, and this being slightly positive, this is where the attraction occurs. That's why ketones and aldehydes are fairly soluble in water. So these are the two main reactions in this unit. Oxidation, and we have the opposite, reduction. So again, primary alcohols goes to an aldehyde, continues on to the acid, because we have so the oxidation requires a hydrogen on that carbon from the carbonyl. In this case, there's only, on the secondary alcohol, there's only one, so it can only be oxidized once. With the primary alcohol, there are two hydrogens there, so it can be oxidized twice. So this is a aldehyde acid. Now in unit 2, you're going to have to actually name the aldehydes and ketones, but you don't have to name the acids because that's unit 3. So you just say acid. Ketones cannot be oxidized because there's no hydrogen there. Now, I'm going to stop here because this is a major reaction you're going to need to know. It's a major reaction on how you test for certain sugars, aldehydes, and ketones. There are two of them, Tollens reagent and the Benedict's test. You'll be using those when you do the carb lab. Okay, so I'm going to stop here because we're getting into reactions. These reactions can be tricky. Okay, so that's it for today. Getting out a little early, but